ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన ఎన్ఎస్ఆర్ ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ ఎన్ఎస్ఆర్ ఇంపల్స్.
So C dash becomes K times C. So that is why capacitance of the parallel plate capacitor increases when you insert some dielectric. When you insert some dielectric. So in the parallel plate capacitors we have derived the what is the capacitance formula. Okay, C is equal to Q upon V, and in that we how to derive delta V. So there we have taken charge Q, so that this is plus Q, this is minus Q, and we know electric field due to this both of them are same direction, which is sigma by epsilon naught. Now when you know the E, potential difference formula equal to ED, so we got capacitance. So this is capacitance of the parallel plate capacitor. When dielectric is kept, capacitance increases. Capacitance increases. In some cases, they will not completely fill the dielectric. For example, this is plate 1. The distance of separation is D. The distance of separation is D. And now only this distance is placed with the dielectric. This is dielectric. So dielectric is nothing but simply insulating material. Okay na? So the thickness of this one as some T. So out of the entire distance D, only T thickness we place it the what? Dielectric. Then what might be the capacitance? If nothing is there, we know the formula. If empty space is there, what is the formula? Epsilon naught A by D. So this plate area is A. But now something is kept. Then how to find out? Now the method you have already. The method is C is equal to Q by delta V. C is equal to Q by delta V. And so you just find out delta V, then you will get the answer. When plus Q and minus Q is there, some electric field will be generated. We already know in between the plates plus Q and minus electric field will be there, which is sigma by epsilon naught, which is you can write this is original electric field. But in the dielectric electric field decreases. So when dielectric is kept, electric field E dash becomes electric field decreases by K times. In the air it is E, but in the dielectric medium what is E dash? E by K. That is why I will write the voltage formula. See, when I am going right like this, it is high potential V plus it is low potential. Now delta V is equal to, we have the formula from electrostatics, potential is equal to electric field into distance. Now this is T na. Now what is the remaining distance? D minus T. This is T, this entire is D. Now what is the remaining distance? D minus T. In the remaining distance air is only there, so electric field is E. So potential difference formula, E into the distance, E into what is the distance? D minus T. This is for air, plus now here also some electric field is lost, some potential difference is lost, means potential decreases. So in the air potential difference is this much, in this one potential difference is E dash into thickness T, because in this potential is electric field is E dash, the thickness is T. Now that is why delta V is equal to capital E into D minus T plus in the material what is electric field I told you? E by K into T. If you take E out, then this is D minus T plus T by K. If you take E common, that will be D minus T plus T by K. Then delta V is equal to E into D minus T I will take out. So 1 minus 1 by K. 1 minus 1 by K. This is I got delta V. Now when you got delta V, what is the capacitance formula? So capacitance formula C is equal to Q by delta V. So Q by delta V is what? E into D minus T into 1 minus 1 by K. But already E formula you know, sigma by epsilon naught. So capacitance will be Q by, this is sigma by epsilon naught, which is also called as Q upon epsilon naught A into D minus T into 1 minus 1 by K. So Q cancels. Now what is C? We got epsilon naught A will go up, then D minus T into 1 minus 1 by K. This is the formula. This is the formula when some dielectric medium is kept. When some dielectric medium is kept. When nothing is kept, when air is there, what is the formula? Simply epsilon naught A by D only. This is with air. When dielectric is kept, distance is decreased, D minus T into 1 minus 1 by K. Right? Now, sir, instead of the dielectric, if metal is inserted, metal is kept. For metal, dielectric constant value is infinity. For metal, dielectric constant value is infinity. So that if the same thickness is kept, the formula will be C is equal to epsilon naught A by D minus T into 1 minus 1 by K value infinity we will keep. So 1 by infinity is 0. So 1 minus 0 is 1. So the formula will be C is equal to epsilon naught A by D minus T. So this is what with parallel plate capacitor. Okay. Right. So now we will see how the parallel plate capacitor charges. So generally you know that parallel plate capacitor has two plates. So we can take two plates, right? Now these two plates are connected to a cell via a switch. So initially at time t0, the charge on the plates is 0. The charge on the plates is 0. Now here no charge present. Now how we do the charging process? So here when we close the switch, at an instant after close the switch, now so from the battery high potential, from the high potential some charge will start, some charge starts. Now this charge accumulate on the positive, this charge accumulate on the positive. And see here I can simply say that, sir, how it is positive? See, when the battery is connected, high potential is there, you know that some electrons on the plate are attracted towards, the electrons are attracted towards the high potential. So when electrons are attracted means electrons are coming. So when electrons are we just removed means, so here electrons are coming means the left charge is positive. That is how I am saying when so that is here switch is connected, switch is in on position, due to this high potential the electrons are attracted, so that electrons will come, so that it will left with some charge plus. You know that removal of electrons is becoming plus charge. Now automatically this electrons will accumulate on the negative, so that this will be negative charge. So this is how in generally how the parallel plate capacitor becomes charged by connecting to the cell. So here within a very short fraction of the time the charge will deposited. So due to this some electric field will be generated, you know, from positive to negative electric field will be generated. Now sir, in how much time the charging process will stay. The movement of electrons will cause the accumulation of charge on the plates. This will be up to when the potential difference between the plates is equal to battery potential, means cell potential. If both are same potential, you know that there is no potential difference, further transfer of charge not takes place. So up to when the plates acquire a potential difference the same as the battery, then up to that only charge flow takes place. Then it stops, the flow of charge stops. Okay, now at that instant let me take some charge Q is there. So that is how you can say that. So on this plate you can say charge is equal to capacitance into voltage or potential. So you know the formula for this one, right? Charge on the parallel plate capacitor. Charge on the parallel plate capacitor is equal to capacitance into voltage. So you can find C is equal to Q upon V. C is equal to Q upon V. Right. So we will see one problem based on this one. So you can find out capacitance of the parallel plate capacitor, and you know that capacitance formula is already for a parallel plate epsilon naught A by D. This is the distance between the plates, and this area is capital A, and you know I am just writing like a parallel lines, but actually this capacitor plate will be like this. These are the conducting plates I told you on already. So these are the like a plates, but now for just easiness I am just drawing the straight lines. Okay, so you know the C value, and you can get whatever values you want. If you want Q, if you want charge accumulated on the capacitor, you can find out Q is equal to CV method. Okay, now we will discuss one problem. For example, there is a spring of constant K, spring constant K is attached to this is, you can take it as ground. The spring is attached to one of the plates of a parallel plate capacitor. One of the plates of a parallel plate capacitor. Okay, now you know that this plate will have some mass m. This plate will have some mass m, so that gravity will act. So gravity will act down, and due to that weight the spring will be extended by some distance. You can say मान लीजिए like L naught. So L naught is the initially extension stretched by the spring. Okay, now my question is, if I accumulate some charge, if I give some charge Q, to the parallel plate capacitor, now automatically you know that this plus will store here and minus it will be stored here. Okay, so plus minus, due to that this negative plate will attract the positive, so that this plate, the top plate will move down by further distance, so that the spring will have one further extension. Now I would like to find what is the further extension. So find further extension of the spring, when charge Q is given, right. So you can take initially the distance between the both of the plates as a d, you know already. Now when charge is given, after charge Q given, you know that the plate will be attracted, because this negative plate will attract the positive plate, so that they will come further down, means that distance will be between the plates, distance between the plates I am taking as some d naught. Okay na, it means this plate further come down by d naught, means the spring is further extend by d naught. Simply what they are asking you, d naught. Okay na, now how to do? So when the plate comes down, the spring extends so that it has some force, restoring force. Now on this plate, now what is the free body diagram? On this plate already weight will be there, mg. Now due to this negative charge on the positive, some electric force will be there, and now spring will give some force which is k into x. But what is x? We know already. This is already initial length is L naught. Now further stretched by d, so L naught plus d. L naught plus d. Now initially when only mass was there, you know that its weight mg is equal to only k L naught. When charge was not given, the plate weight is equal to spring force, mg is equal to k L naught. This is equation 1. Now after charge was given, can I say the downward force equal to upward force? So force plus mg must be equal to k into L naught plus d, means k L naught plus kd. But already we know that mg is equal to k L naught. Can I cancel? Now what is f? F is equal to kd. F is equal to kd. Sorry, this is L naught and this is d naught. So further is d naught. So k d naught. Now what is the force? What is the force between the plates? See, force is equal to electric field of the plate into the charge is equal to k d naught. Now don't you know electric field? Array, if this is the one plate, this is the positive plate, due to this positive plate electric field will be like this. Due to this positive plate electric field will be like this, which is already we know that due to single plate sigma by 2 epsilon naught. Due to single plate sigma by 2 epsilon naught. Now in this field this plate was kept. This is negative plate infinity. So can I say this field will attract it, because this plate will attract the negative, so that what is the E you can take only sigma by 2 epsilon naught into q is equal to k d naught, send d naught this side. So this is how to find out the spring constant if d naught no, or what is the further extension means d naught they are asking. So you can send a d naught and k down. If you know the spring constant value, then sigma into q by 2 epsilon naught k is equal to further extension. So this is how I have used a parallel plate capacitor with a force concept. Okay na, right? So this is what related to a parallel plate capacitor. We will see lot of number of problems in the coming concepts. Okay, so because there are dielectrics when they kept in between the parallel plates, what is the effect? So there are lot of things to discuss. Chalo hum abhi we will go forward to the another concept. Okay, so we are going to the next one more concept called as combination of capacitors. Combination of capacitors. See, like have you studied in class 10th in current electricity chapter, there are lot of number of resistors will be given. They may connected in series, they may connected in parallel via a battery, so that they may ask you to find out the equivalent resistance. So they will give the diagrams like this. This is one resistor, this is one more, right? So for this again one more resistor. Likewise they will give number of resistors, and now they will ask you to find out the equivalent resistance, means which has the same effect as the whole the resistors. So you can replace the all the resistors with a single resistance called as a equivalent resistance. Now in the same way, in the capacitors also we have the same thing, series and parallel connection of the capacitors. So as we did in the current electricity, we do the same for capacitors. Okay. Now, so what we need to find first? Effective capacitance. Means out of the whole number of capacitors given, we need to solve the whole things and we need to get a single capacitor, that is called as equivalent capacitor, right. Now we will see in this one, first one, there it is very important topic. The first one is series connection, series combination of capacitors, series connection, and we have series connection also parallel connection. So we will see first series connection. Okay, I am taking some capacitors C1, C2, C3 and sir, how they are said to be connected in series? The negative plate of the right. So how it is connected in series? The first, this is called as a positive plate, this is negative plate. So the negative plate of the first capacitor C1 is connected to the positive plate of the capacitor C2, and the negative plus capacitor of second one is connected to the positive plate of the capacitor C3. If it is connected like this, then it is called as a series connection. Okay. Now we will, with the help of a switch, will connect a battery. So I have connected here 3 capacitors, and I told you negative of the first one is connected to plus of the second one, negative of the second one is connected to the positive of the third one. In this manner, if it is connected as a series. Okay. Then if suddenly switch is closed, from the battery of a voltage V you can take, potential V you can take, from the battery charge will start. Let me take small charge Q is started from the battery. Now this charge will flow in the circuit and it will be deposited in the first plate of the capacitor, and you know that for a parallel plate capacitor, charge always present inner surfaces. By using the Gauss law I proved that on the outer surfaces charges are 0. So now this charge Q, the charge Q will be deposited first here. Now, and we already know that for a parallel plate capacitor, the inner surfaces must have equal and opposite charges, hence this Q will be again deposited in the second plate. And now as these two plates are connected by the conducting wire, now initially when switch is not closed, means battery is not providing the charge, in that case the total charge is 0 because they are like this, nothing charges, no charge is present on that, so net charge is 0. So according to conservation of charge, initial charge is 0, means now also the total charge must be 0, means now it got negative, means this plate must get positive. Sir, how much? This is minus Q, this will be plus Q, this will be plus Q, and meanwhile you know that if it is plus Q, this will be minus and this will be plus Q. So now tell me one thing, due to the flow of Q on each capacitor, what is the charge? So on the charge on each plate is each capacitor is Q, and you know that if it is plus and minus, the total charge is 0, but we conventionally we can take the positive charge as the charge of the capacitor. Now here plus Q minus Q is there, but what is the charge of capacitor? Q you can take, plus Q. Okay na? Right. Now on each capacitor, what is the charge? On each capacitor, charge is Q. Charge is Q stored. Means in series connection, charge through all the capacitors is same. Now, so here for the flow of charge, some potential must be dropped, because you know that from positive plate to negative plate there is a potential difference. Potential will drop. So that potential drop we will take it as a V1 here. This is V2. This is V3. Now all those potentials must be equal to the potential given by the battery or a cell. So I can say that the sum of the individual voltage drops or potential drops across each capacitor is equal to given by the cell. So V is equal to V1 plus V2 plus V3, but already you know that Q is equal to CV formula for capacitor. Now what is the V here? V is equal to Q by C, using this one. So charge is Q by what is the C? See, we are taking out of the 1, 2, 3, we are taking this one as a some effective. So C effective is equal to V1. In the first one, what is the V formula? Q by C means Q by C1, because you know that charge is Q, plus Q by C2 plus Q by C3. As we cancel Q, then what is the value we will get? So 1 by C effective is equal to 1 by C1 plus 1 by C2 plus 1 by C3. I think this the same type of formula you got in current electricity for parallel resistors. Here in series capacitors, ulta. Now if there are only C1, C2 present, in the circuit, now what is C effective? 1 by C effective is equal to 1 by C1 plus 1 by C2. 1 by C1 plus 1 by C2, or you can do like this also, do the LCM. So 1 by C effective is equal to, LCM will be C1, C2, and here you will get C2, here you will get C1, C2 plus C1 also called as C1 plus C2. Now we want C effective, so topple it. So C effective is equal to C1 C2 by C1 plus C2. When two capacitors are connected in series, directly use the formula product of the capacitors by sum of the capacitors, then you will get the answer. So here in the series connection, sir, what is same? Charge on every capacitor is same. Sir, what is different? What is sharing? The potential sharing, the V1, V2, V3. So sharing is potentials and constant is charges, right? Now, so they might ask you, what is the ratio of the charges? Q1 is to Q2 is to Q3. So charges are same, so that 1 is to 1 is to 1. 1 is to 1 is to 1. Now if they ask you what is the ratio of the voltages, if they ask you what is the voltages ratio, now as you know that Q is equal to CV, but in series connection Q is constant. Charge through everything is same, matlab Q is constant. So when CV is constant, can I write V is inversely proportional to C, bringing C down. So voltages, potentials across each capacitors is inversely proportional to C. It means V1 is to V2 is to V3 can be automatically written as 1 by C1 is to 1 by C2 is to 1 by C3. It means the capacitor has a more capacitance will drop less voltage. In the series connection, the capacitor has the more capacitance that can drop less voltage. We will see with an example, okay. So I am just taking a small example where two capacitors are connected. For understanding, there is a battery. Now this is 4 microfarad capacitance, this is 6 microfarad capacitance, and it is 12 volts is given. Now when switch is closed, so charge will start. Now they might ask you what is the charge, what is the total charge drawn from the battery, So for that you should find what first? Effective capacitance. We have 2 capacitors here, so we replace these 2 capacitors with a single capacitor. What is the formula for C effective? So C1 C2 by C1 plus C2. What is C1 value? It is 4 micro into C2 value 6 micro by 4 micro plus 6 micro. It will be 24 micro into micro I will write, and this is 10 micro, so that 1 micro cancels. Now what is the equivalent capacitance? 24 by 10 is 2.4 microfarad. Farad is SI unit, microfarad, right? CV equal to CV. So charge is equal to C effective is 2.4 microfarad into the battery voltage is 12. The battery voltage is 12. So you can take for a simple thing I am taking this is 10 for my easiness. So 10. So 2.4 into 10. So it's 24 micro. This is charge, so that coulombs. So 24 microcoulombs will be taken by the battery, taken by the system from the battery. Now this 24 will go and passes through the both of them and again come to the cell. Means what is the charge in the circuit? 24 microcoulombs. So through each capacitor charge is 24. Now I want individual drops. I want individual potential drops. So potential drop across first capacitor, that is V1 I want. As you know, the formula for V is Q equal to CV means V equal to Q by C. So Q upon C1. So what is the Q we have? 24 microcoulombs by C1, already we know that 4 microcoulombs. 4 microfarad. So micro cancels, this will be 6 volts. Means what is the potential drop across V1? 6 volts. In the same way V2, sir, out of 10 volts, here 6 volts is dropped. Means how much is there? 4 volts, remaining 4 volts. So that can be found by like this. This is 24 microcoulombs by 6 microfarad. It will be 4 volts. So that is why see this battery having 10 volts, like say 10 rupees. So to cross this capacitor 6 rupees given and remaining 4 rupees given here. So total is this 10 will be used here. So that is why we can say that in the series connection, voltage is the potential drop is inversely proportional to capacitance. More the capacitance, less the voltage drop. See in this one more, what is the more capacitance? 6. Here less drop. See less drop means 4 volts. So this is how to solve these series circuits. So we will see number of problems, no problem, right? So this is basically series connection of the capacitor. Now we will see what is the parallel connection of the capacitors. So parallel capacitors. So parallel connection. Sir, now the first question is, sir, when it is said to be connected in parallel? So when it is said to be connected in parallel. Now the capacitor has 2 plates, right? The positive plates of the all capacitors are connected to the positive terminal of the battery and negative plates are connected to the negative terminal of the battery. Then you can say that is said to be connected in parallel. I will take here, this is first capacitor, second capacitor, third capacitor. You know this side one plate, this side one plate. Okay. Now, so this is positive plate, this is negative plate. So I can say that all these plates are connected at a point, all the remaining plates are connected at a particular point. So I can say that this end is connected to the positive terminal of the battery, this end is connected to the negative terminal of the battery. So all ends are connected to the positive, the remaining plates are connected to the negative end. Then this type of connection is called as series connection, as the capacitor C1, C2, C3. Now here we would like to find out the equivalent capacitance. See, we have three capacitors, we need to solve them, and we have to find out a single capacitor which shows the same effect. So these three capacitors, instead of these three capacitors, we are writing a single capacitor called as C effective or C equivalent, which has the same effect. Okay, now if some charge Q is taken, now we can say that, so Q is equal to C effective into V. So we want to find out that C effective, right? Now here, if I take the battery voltage as V, it means that positive potential is V, negative potential is taken as 0. So this is V, this is 0. Now tell me, for this C1 capacitor, what are the endpoints? V1 and 0. What is the difference in voltage? V minus 0 is V. For the second capacitor, endpoints are V and 0. Now what is the difference? V minus 0 is V. And third capacitor, the same endpoints. If endpoints are same, they are connected in parallel, no? And what is the first thing which is constant in parallel? In parallel, potential difference across capacitors, is same. So V is constant. Now when V is constant, now see, if some charge Q starts from the battery, now automatically this has to split into Q1, Q2, Q3, because this has to split into three ways. So that is why I can say that again this Q will become like this Q2 will come like this Q3 will come like this, again they have to come into the cell. So that is why the sum of the charges passing through each capacitor will be equal to the net. So Q is equal to Q1 plus Q2 plus Q3. Now what is the Q formula? You know already, C effective into V. So C effective into V. Now what is the Q1? Through this one, capacitance is C1 and the voltage is same there. So I can say that it is C1V plus C2V plus C3V. Now you can take V common. So C1 plus C2 plus C3 is equal to C effective into V. V cancels. Now what is C effect formula we got? Simply sum of the capacitors. Sum of the individual capacitors is called as the equivalent capacitance in parallel. See, ulta, in resistors, series resistors R1 plus R2 plus R3, but in capacitors, in parallel connection R1, C1 plus C2 plus C3. Okay, so this is how to find the effective capacitance for the parallel plate capacitor, right? We will see with an example. So here, what is the potential drops across each capacitor? V1 is to V2 is to V3. V1 is to V2 is to V3 is all potentials are same, so that 1 is to 1. Now you know that Q is equal to CV. Q is equal to CV. So that now here V is same. Hence Q directly proportional to what? C means more the capacitance, now it will take more charge. More at a given potential, the capacitor has the more value, will take the more charge. Capacity, what is the meaning of capacity? At a constant potential, the ability to hold the charge. That is why all at same potential, now which has the more capacitance, that will take the more charge. So that is why the charge ratio Q1 is to Q2 is to Q3 will directly proportional, so that C1 is to C2 is to C3. Okay na? Right. Now we will see one example based on this one. So I am just taking parallel connection of capacitors. First one is this one, and the next one. There are two capacitors, again 4 microfarad. Sorry, I am taking this one as 3 microfarad, this one is 6 microfarad. Both of them are connected to a cell of 12 volts. Okay na? Right. Now what I told you, the positive terminal is 12, the negative terminal is 0. Means here 12 volts, here 0 volts. And here also see there is no drop, means here 12 volts, here 0 volts. Now this capacitor endpoints are 12 and 0. This capacitor endpoints are 12 and 0. Then automatically they are in parallel. Now how much charge will flown from the battery? So to find out that one, we should find out first effective. So what is the C effective? C effective in parallel is C1 plus C2. So what is C1? 3 microfarad, and this one is 6 microfarad. Then automatically what is this capacity effective? 9 microfarad. 9 microfarad. Now, so what is the charge will be drawn? Q is equal to formula C effective into V. So C effective is 9 micro into V is 12. 9 12 is a 108. So you can say that 108 microcoulombs will come from the battery. Sir, this charge must be split into two. Must be split into two. One is Q1, the remaining is Q2. So I already told you in parallel voltage is same. So Q directly proportional to C. Q directly proportional to C. Now you can say that Q1 by Q2 is equal to C1 by C2. Q1 by Q2 is equal to C1 by C2. Now, so can I get Q2 from this one? Can I get Q2? Q2 is equal to C2 by C1 times Q1. Okay na? But already I know that what is the sum of the charges from the battery? That the total charge Q must be equal to Q1 and Q2. So Q is equal to Q1, I am writing as a Q1 plus in the place of Q2 I will write this one. So it is C2 by C1 times Q1. Now taking LCM as C1, so LCM as C1. Now taking Q1 out, common Q1 out. Now this will be C1 plus C2 is equal to Q. Now I would like to find Q1. So send this entire data left side. So Q1 I will get C1 by C1 plus C2 into charge. This is how charge will divide. Charge will divide in the parallel plate capacitors. Charge in the first capacitor is equal to first capacitance by total capacitors into the charge coming from the battery. Now in the similar way, if you want Q2, substitute here, you will get the answer as C2 by C1 plus C2 into Q. Now simply I will tell you, as the voltage is same, Q directly proportional to C, right? Here the ratio also Q1 by Q2 is equal to C1 by C2. Now see, how many capacitors are we have? 2. One is 3, one is 6. Now what is the ratio of the capacitors? 3:6. 3:6 means the ratio of capacitors C1 is to C2 is 3:6, means 1:2. Means charge ratio must be 1:2, means charge will split into 1 and 2 parts. Means how many parts? 3 parts. So the coming current, we should divide the coming current into 3 parts. Array, what is the total coming charge? Coming charge will be, we know, 108. What is the coming charge from the battery? 108. Okay, that 108 you divide into 3 parts. 108 by 3, 108 by 3, 108 by 3, 3 parts. So 108 by 3 how much? So 108 by 3 is 36, right? Okay. Now 36, 36, 36. Now in the first capacitor how much ratio? 1 is 1 ratio. So that is why through the Q1 one part only goes. So I can say that Q1 will be 36 microcoulombs. Through the capacitors 2, what is the charge? 2 parts must go, means 36 plus 36 means 72. Now what is the total? It must be 108. So that is how the charges will split. The charges will split in the parallel capacitors. You can directly by heart the formula. Charge through first capacitor is equal to its value by total sum into the total charge coming from the cell. Okay na? Right. Now we will see mixed grouping means like mixed cell, mixed connections, like in that series connection will be there as well as parallel connection will be there. Now how to find out those type of problems. So let me take a correction like this. This is A, this is B. How many capacitors we have? 3. So first one is 2 micro, the second one is 4 micro, okay na? This is 3 micro I will take, this is 2 microfarad. So we have 3 capacitors between the A and B. Now I would like to find out what is the equivalent capacitance. So find equivalent capacitance. Now you need to identify which of them are in series, which of them are in parallel, right? See, if I take this node as a C, now for the 4, what are the endpoints? C and B. For the 2 endpoints are C and B. Now endpoints are same means they are connected in parallel. So here 4 microfarad and 2 microfarad are in parallel. So in parallel, you know C effective already in parallel, nothing but resistors in series. So C1 plus C2. So it is 4 plus 2, it will be 6 microfarad. Now, so instead of these two, I can write 6 there. Now that 6 and this 3 series, because same branch, if current enters here, that has to pass through the both. So that 3 microfarad and 6 microfarad are in series. Now what is the net equivalent? In series, what is the formula? Product by sum. So C1 C2 by C1 plus C2. What is the C1 is 3, C2 is 6. 3 into 6 by 3 plus 6. 3 into 6 is 18. This is 9. So 18 by 9, 2 microfarad. So this is how you can do the combination capacitors. Okay, combination capacitors.